Hello everyone. In this video, we are going to learn how to fit a Arima model for a given variables. So here we will go through the question. Make use of RStudio to fit Arima model for the following particulars. Forecast, check accuracy of the returns for next 5 trading days. Means we have to fit estimate the log returns using the forecast. We have to forecast the variables as forecast the log returns, as well as we have to check the accuracy of the model. So here it is given the symbol NACI, that is normally Nifty symbol from Yahoo Finance, from 1/1/2020 to 2024, means around 4 years. So we'll go with the start with RStudio first. So in RStudio first we will be using QuantMod for extracting data from Yahoo Finance. Then we are going to use T series for calculating, checking the stationarity of the data set and plotting. Then we are going to use forecast for the forecasting the variable. So these three packages we are going to use. First one, symbol, we will extract the data set first based on a question given. Symbol equal to, in double quote, NSEI, start date equal to, in double quote, 2020 0101, so 2020 0101, end date equal to 2024 December 31st. We will extract the data from website Yahoo Finance. So we are using get symbols. In that we are using symbol, that is the first variable whatever we have defined, that is a ticker NSCI. Then source src equal to Yahoo, comma, from which date, that is a start date, comma, to equal to end date. So we'll run the command first and we have received the Nifty values. Okay, next one, we'll go to the, we are going to extract the closing price here. So Nifty equal to NA dot omit, sorry, first we will extract the closing price. So CL of NSEI, will run this code. So we got Nifty, only closing price we got. Next one, we are going to find R Nifty equal to NA dot omit. We are going to find the log returns. So yeah, I will just write here what command we are writing. So this is for extracting from Yahoo Finance. Then extracting the closing price of Nifty. Then calculating the log returns. So NA dot omit, open bracket, diff of log of the closing price is located in Nifty, so I will mention Nifty. So we'll run the code. So we got log returns, all are lesser than 0.00. So log returns are done. Now we got the variable. Now we have to check we have to plot it first. So plot dot ts r Nifty. So we got the plots. Check the stationarity. So ADF dot test R Nifty. So lesser than 0.05 means data is stationary. Then find the optimal lag. lag of the Arima model. So we are using auto.arima of R Nifty, auto.arima of R Nifty, comma IC equal to AIC, that is archaic information criteria. Based on that, I want to check the optimal lag of Arima model. So information criteria is AIC, archaic information criteria. Trace equal to true. Control enter. So we got here 302 is the optimal lag of this model. So based on this optimal lag, we'll fit the Arima model. So here fit Arima model. So here it is Nifty. So I will mention Nifty Arima equal to any name you can mention for this variable, Arima model or Nifty underscore Arima, Arima underscore Nifty, any name you can mean, or just mention X also, no issues. So Nifty Arima equal to Arima, that is in small case, R Nifty, comma, order equal to C of 3, 0, 2. That is my Nifty Arima model. So again, to check the final value, again I will run the model. So for in here I have run that, defined the model. Now I'm running the model. So we got AR1, AR2, AR3 values, MA1, MA2 values along with their standard errors as well as the intercept. So this is my output. So I will take this coefficient, Arima coefficient. I will copy this. I will go to new world document. I will paste it here. This is my R output. Later we'll interpret this. Then we'll go to find out the residual test, or we can say diagnostic test or check. So first we will define the residual variables, so which is not explained in the model. We are going to check whether these residuals of the models are normally distributed or not. So first we will mention ET equal to residuals of Nifty Arima, that is our Arima model name, Nifty Arima. We have defined ET. Now plot dot ts ET, think it's not okay. So we got again clustering, we can see here. Then ACF of ET, that is autocorrelation. Only majority of the lags, if I zoom into this, yes, majority of the lags lying behind this, so only few are crossing that, so no issues. PACF, that is partial autocorrelation of ET, again similar thing, only few lags are there. Next one, histogram, so GG histogram of ET, sorry, not here, I have to put it here in sorry, I was typing in console. Okay, one second. PACF. Okay. GG histogram of ET. So you can see this normally hovering around 0, so it's normally distributed. Then we are having box test. So box dot test, so variable will be ET, comma lag equal to 10, Then we are having type equal to box comma fit df equal to 3. So we got box test here, p-value is lesser than 0.05. So diagnostic check is completed here, model is fit. Now based on this, after diagnostic check, we are going to forecast model we are going to define. So Nifty forecast equal to forecast of Nifty Arima for, it's given in the problem for 5 trading days. It's given here next 5 trading days. So here H equal to 5. So we have defined the forecast model. Now we will run the forecast model by just mentioning the name of the model, Nifty forecast. So when we mention it, yeah, I will just go through this. I think it's not yet defined. So we'll run this. Yes, these are the 5 estimation. Out of sample, the moment we took Nifty here, you can see the whatever variables are there, 1 to 1234 observations were there when we defined the variable, when we extracted the log returns. Now 1235 onwards, this will be our log returns, that is 0.00 1446, 0.00 minus 0.0038957, like this. So this is my out of sample forecast. To check the accuracy of the model, so that is accuracy of forecast model, we are using the code accuracy of our forecast, that is forecast model name is Nifty forecast. Let's control enter, and you can see here this is my Nifty forecast. So this will be the final thing to do. Okay, so what you are going to write here, so whatever code we have written, first we'll copy this. So these are the codes I have written, control C. I will write here R script for Arima. So I will remove the line spacing to 0 and little bit of font style change. Okay. So this is the library. Then we have extracted closing price. Then we have calculated log returns. We have plotted this. We have find the optimal lag. We have fit Arima model. We have checked diagnostic. We have modeled the forecast the model. We have checked the accuracy. Then after that, okay. So this is our accuracy model is output is here. Accuracy model, that is again yeah, we'll just put it like this, it's better. Infinite 0.7 and 0.02. So this is my ME, this is my RMSE, that is root mean squared error. Then this is mean absolute error. And this one is mean absolute percentage error. This infinity. Mean absolute squared error is this one. Then we got, I think, Go back to this ACF MASE. Okay, 1 second. MPE is missing. Okay, MAE. This is MPE. This is MAPE. Then this is MASE. Okay, this is ACF1. Okay, the majority of the values are lesser than 0.0. You can see only except RMSE root mean squared error. So you can see almost you can see this one MAE almost close to 0, and this one also MA also almost close to 0. So we can see that the forecast model is very much accurate. That is how we can analyze this accuracy output. Then this one Arima output, it will be like the equation. So Arima model equal to plus again plus again this one plus, and this is again minus, and this intercept, that means intercept normally you used to write at the beginning 0.1234. So this will be my 5e minus 0 2 minus 4. So standard error I will remove. So this is also not required. This is my AR1 lag. So I will use the equation to write the symbol. So this will be R R. This will be T minus 1. Again, and copy paste for this. This is Arima AR2, AR3. This is error 1, error 2. Okay. This will be 2. This will be 3. That is AR3. Then this one, this is error term. So equation, I will go back to the symbols and I will select this one. That is residuals. Then again this one, I will check this. Again, I will make it error term, and this will be 2. Okay, so this is my RT equal to. So normally Arima is a mean equation, not the variance. So RT equal to. So this will be my equation, Arima equation. So this is the accuracy of the forecast model. This is the Arima model. Then we can take these values also, log returns. You can see the moment. Okay, I think I didn't plot the log this one forecast. So you can write plot nifty forecast. The moment you run the for plot option, not plot.ts, just the plot, you can see this is the forecasted values plotted here. Since it is 5 years data, that's why it's showing very smaller it is. If you take the, if you zoom into that image, you'll get the clear picture. Yeah, I will try to put it here. So this is my Arima final answer. This is the output. This is the equation. This is the accuracy output, and this is the forecast. First I will put the forecast values here. These values are not required, only log returns are enough. Okay. So these are my log returns. Forecasted values. This is the Arima equation. This is very much important. The moment you see, the thing is that in every time R script, it is like a software. Anyone can get the output. How to analyze the output, that is important than getting the output in the software. So you should know how to put it in equation format, how to analyze this. So 24% variations are explained by 24%. This explanation you can mention 24, around 25% variations are explained by yesterday's log returns, 64% by day before yesterday, around 13% from 2 days back or 3 days back. Similarly, yesterday's residuals having significant impact up to 17%, and day before yesterday's residual impact is around a negative impact of 64%. When other things remain constant, when there is no variation in these log returns of AR1 and AR3 and MA2, even after that around 0.0005, not even 1% variation, you can find it in log returns. This is how you can interpret all these 5 values. So these are self-explanatory. How much you can just multiply into 100, and in that way proportionate impact you can mention. So this is how you can analyze the equation. These are the forecasted values. If I able to get the copy, I will paste it here. We'll see whether it's possible to forecast. Is it possible to zoom? So just zoom into that. I don't think I will get the accurate one. We'll check. Since I couldn't zoom in and the values are of 4 years, you couldn't get much. Yeah. So these are the forecasted values. You can see almost that they are hovering around 0.00. If you go back to this, it's hovering around 00 value because it is a log return. So this is how you can use Arima for modeling the modeling and forecasting. Okay, I hope you find this video useful. Thanks for watching.